Hello, good morning, student. Welcome our channel, the one and only physics points. And today I have started discussions of the new points, new concept about the physics. The name of the chapter is heat. When we listen the word heat, we find one words in our mind, that is the temperature. And heat and temperature both are the different physical quantities, but some amount of interrelationship between in heat and temperature. First of all, we just discuss about the interrelationship between the heat and temperature. What is the basic difference between the heat and temperature? Then we study some amount of parameters of the heat, that is the latent heat, specific heat, and what are the more main importance to study these chapters. The heat, just take the heading, that is the heat. Heat is one form of energy. Heat is the forms of energy. It is the form of energy. Heat is the form of energy. This also known as the thermal energy. This is also known as the thermal energy. Heat is one form of energy, but the temperature it is in the fundamental physical quantity. But the temperatures are depends on the heat, and heat is does not depends on the temperature, because we supply some amount of heat to substance. Substance gets increase their temperature, because the temperature it is a physical quantity which are depends on the heat. To change its temperature, we must require some amount of heat. Because if according to the Newton's first law of motions, if we want to move a substance, a molecules which having some amount of mass, we need some amount of force to move that amount, that molecules, that substance. But consider, it is and vessels which are containing the liquids, any liquids. Then how the heat is works, when we supply some amount of heat to that substances, how it can be work. The liquids which having some molecules, they are randomly moving inside that liquids, inside the vessels. The vessels which are containing by the liquids have some smallest particles or the molecules which randomly moving with some amount of velocity. This v is the velocity of particles, velocity of a liquid particle. That is, the v is the velocity of the liquid particles. When we supply some amount of heat to that liquids, that means heat is one form of energy. According to the law of conservation of energy, energy neither be created nor be destroyed. It can convert one form to the another form. Heat is one form of energy, and it can be supplied to the liquid. Then these heat energy are converted into the kinetic energy of that molecules or the particles of liquid particles which are randomly moving inside the vessels. That means the velocity of the particles are vibrated more frequently, more vigorously as compared to the previous, before applying some amount of heat. That means the heat energy is converted into heat energy is converted into the kinetic energy. The kinetic energy, the heat energy is converted into the kinetic energy of particles or particle of substances. This is the main functions of heat. Heat is one form of energy. This is the main concept we are studying. Heat is the one form of energy. When we supply some amount of heat, the particles which are moving, randomly moving inside the vessels, inside that substance, they are more vigorously, more frequently moving. Then they have more amount of velocity. If the velocity of the particles is more, that means the kinetic energy of the particles is increases. The kinetic energy is 1 by 2 mv square. Half is constant mass. M is the mass of the particle, that particles which are randomly moving, and v is the velocity of that particles which can be increases when we applying some amount of heat of that vessel, of that substances. Then the kinetic energy is directly proportional to the velocity, and heat energy is the responsible, it is first responsible physical quantity which are increase the velocity of that particles which are randomly moving inside the vessels or inside that particles. Consider they have two vessels, that is the vessel A or the two substances, substance A and B. The substance A having the 20 kg of the mass, it may be solid substances 20 kg, and substance B which having the 200 kg of their mass. But they both have same temperature. The both substances which having the same temperature, that is T1, it must be equal to T2, that is considered 35 degrees Celsius. I want to increase the both temperature. I want to increase the both substance temperature, that is T1 and T2 up to the 40 degrees Celsius. That means T1 is must be equal to T2. We can increase up to the 40 degrees Celsius. Temperature of both substance A and substance B will be increased from the 35 degrees Celsius to the 40 degrees Celsius. That means we require different amount of heat to increase their temperature, because the substance A having the 20 kg 20 kg substance and B having the 200 kg substance. But as compared to the B and A, B having the more amount of particles, more number of molecules of that substance is, and A is the less number of particles inside the vessel is as compared to the B. That means we require more amount of heat to increase or raise the temperature 5 degrees Celsius of the substance B as compared to the A, because they have different number of particles or molecules of that substances inside the substance A and substance B, or a vessel A and vessel B. It is the main important things, because the temperature of both particles are same but heat is different. This is the second different point or second difference between the temperature and heat. Now the next point, what is the latent heat? This is the most important points which we are studying in this lecture. Please, what is the latent heat? Okay, next one is latent heat. There are two types of the latent heat. Latent heat, the amount of heat required to substance which can be changed at its state of matters. This is the main simple definitions about the latent heat. The amount of heat, it is the amount of heat required, the amount of heat required to change its state of matter, change its state of matter of the substance. Change its state of matters of the substance. This is called as the latent heat. There are two types of the latent heat. First one is the latent heat of sublimation, latent heat of sublimation, sorry, a lot latent heat of fusion, and latent heat of vaporization. Latent heat of fusions and latent heat of vaporizations. The next point, what is the latent heat of fusion? The latent heat, the amount of heat, it is the amount of heat required to change its state of matter. If the solid is converted into liquid, the amount of heat will be required to convert one substance from the solid to the liquid. This amount of heat is called as a latent heat. It may be stated the name, the latent heat of vaporization, sorry, latent heat of fusion. latent heat of fusion. The amount of heat required, the amount of heat required to change or to convert, to change solid substance into liquid substance, liquid substance. This is called as the latent heat of fusion. You must written in the bracket, which is the heat converted solid to liquid. It is a key points to understand the heat which is required to convert the solid substance to the liquid substance. This heat is called as latent heat of vapor fusions, because latent heat which is change the state of matters, and heat of fusion which is change the solid to liquid. The next point is latent heat of vaporizations. We will get the ideas what we are discussed in these points. Latent heat of vaporization, latent heat of vaporizations. The amount of heat required to change the liquid substance to the vapor or gas, this is called as the latent heat of vaporization. The amount of heat, the amount of heat required to change liquid substance to the gases or liquid substance into the vaporizations. To change liquid substance, liquid substance to, it can be changed liquid substance into to the gas or vapor is called latent heat of vaporizations. There are 2 points which are interrelated between the latent heat of vaporizations and the latent heat of fusion, that is the melting point and boiling point. Latent heat, it is definitions for converting the solid to a liquid to gases in the form of heat. But the melting point and boiling points, it is the point on which, or it is the amount of temperature at which, this is definitions of changes the states of matter in the form of temperature. That is, the first point is melting point. Third one, it is melting point. Melting point. The point on which, or the temperature at which, the temperature at which, the temperature at which the solid is converted into liquid, this temperature is called as melting point of that substance. The temperature at which solid substance with solid substance is converted into liquid substance, converted into liquid substance. This temperature is called as melting point. Liquid substance, this temperature is melting point of that substance. This substance is called as the melting point of that substance. The next one, it is related to the latent heat of vaporizations. The fourth one is boiling point. The temperature at which the temperature at which just change the two words solid. Instead of the solid we must be substitute here liquid, and instead of the liquid we must be substitute here or take here gases. Then the temperature at which the temperature at which temperature at which liquid substance is converted into gases or vapor. Liquid substance is converted into gases is called as boiling point. This temperature is called as the boiling point of that substances. Just revise what we are discussing on some definitions which are written on the boards. Before vanish it, just revise and note down. What is the latent heat? The amount of heat required to change its state of matters is called as state of matter of the substance. This amount of heat is called as the latent heat of that substance. There are two types of the latent heat which are converted solid to liquid, liquid to gases. That means they have two stages and two different amount of heat is required. One is latent heat of fusion and another one is the latent heat of vaporization. What is the latent heat of fusions? The amount of heat which is required to change the solid substances into the liquid substances. There are solid to liquid. This is called as the latent heat of fusion. And second one is the latent heat of vaporization. The amount of heat required to change the liquid substances into the gaseous substances. This is called as the latent heat of vaporizations. When there are two state changes parameters in the form of liquid, in the form of heat, this is as similar some amount of phase changes or state changes parameter in the form of temperature also. Then melting point and boiling point. The temperature at which the solid is converted into the liquid substance or solid substance is converted into the liquid substance, this temperature is called as melting point. And the boiling point, the temperature at which the liquid substances is converted into the gaseous substances, this temperature is called as boiling point. Okay, the next point is the specific heat. Okay, let's start. The next point is the specific heat. Specific, the amount of heat which is required to raise 1 degree Celsius temperature of 1 gram substance is the unit mass called as specific heat of the substance. And next point is the specific heat capacity. Please take the heading, that is the specific heat. Specific heat. It is means we taken a 1 gram substance or unit mass substance which having the temperature that is 28 degrees Celsius. Consider the temperature of a substance, 1 gram substance which having temperature 28 degrees Celsius. That means we require some amount of heat to raise these 1 gram substances up to from 28 degrees Celsius to 29 degrees Celsius. The amount of heat required of that 1 gram of substance to raise 28 degrees Celsius to 29, that means the 1 degree Celsius temperature, this amount of heat is called as the specific heat. I recall again, it is the 1 gram substance having the unit mass substance, any substance which having the temperature 28 degrees Celsius. I want to supply some amount of heat to that substance, at 1 gram substance, to raise the temperature 1 degree Celsius. That means 28 degrees Celsius into the 29 degrees Celsius. The amount of heat required to convert 28 degrees Celsius temperature to 29 degrees Celsius of that 1 gram substance, this amount of heat is called as specific heat. The amount of heat required to raise 1 degree Celsius temperature 1 degree Celsius temperature of 1 gram substance 1 gram substance. If this is liquid, that is the 1 ml substance, 1 gram substance, this amount of heat, this heat is called specific heat. Specific heat. Then this is the specific heat of the different substance is different because they have some different thermal properties. They show the different thermal properties. That means the specific heat of the different substances, or it may be copper, iron, they have different specific heat. The second point is the specific heat capacity, which is shows the thermal property of the different materials. Second one is specific heat capacity. Heat capacity. The unit of specific heat, we amount heat required. Heat is the forms of energy. That means they have unit joule per required to raise 1 degree Celsius per unit temperature. That is 1 uh, Kelvin into the 1 gram substance, that is kg. This is the joule per Kelvin per kg. This is the unit of specific heat capacity, joule per Kelvin per kg. Then the specific heat capacity, it is the amount of heat stored in the 1 gram substances which is raised 1 degree Celsius temperature. The specific heat capacity, it is the amount of heat stored in 1 gram substance to raise the 1 degree Celsius temperature of that substances. This is called as the specific heat capacity of the substances. The specific heat capacity of the substances is different of the different substances. In the next lectures, we are just studying about the anomalous behavior of waters. The anomalous behavior, that means the all substances which can be expand or compressed at the time of heating or cooling respectively. But in between the temperature range from 0 degrees Celsius to 4 degrees Celsius, the water shows their anomalous behavior. That means they doesn't follow the rules as all substances will be followed. That means if we are cooling from the 4 degrees Celsius to 0 degrees Celsius, every substance gets contract, but the water get to expand. If we heating from 0 degrees Celsius to 4 degrees Celsius, every substances will be expand, but water gets contract. This is the anomalous behavior of water. We will discuss in the next lecture. Thank you.